This experiment deals with chemical formulas. We will be looking at the formation of zinc chloride and determining its empirical formula. The objective of this experiment is to determine the empirical formula of zinc chloride. This will be done by reacting elemental zinc metal with hydrochloric acid. By measuring the mass before and after reacting, we can calculate the ratio of moles of chlorine to moles of zinc. There are two types of chemical formulas we will talk about. The first, the empirical formula for a chemical compound, is the smallest integer mole ratio of all elements in the compound. We can contrast this with the molecular formula, in which the exact mole ratio of all elements is given. For many compounds, the molecular formula and empirical formula are identical. For example, the compounds magnesium chloride, sodium phosphate, and methanol do not have an empirical formula that is different from the molecular formula. In the case where the empirical formula is different, we just divide by the largest common factor. For example, the empirical formula for C4H10, butane, is C2H5. We observe that the numbers 4 and 10 have the same largest common factor of 2, and then we divide. The empirical formula for glucose, which is C6H12O6 as a molecular formula, is CH2O. In this case, the largest common factor of 6 and 12 is 6. Note that it is possible for two different compounds to have the same empirical formula. An example of this is glucose, C6H12O6, and formaldehyde, CH2O. Both of them have the same empirical formula, CH2O. In order to calculate the empirical formula of a compound, we need to know the number of moles of each element in the compound. Note that this is not sufficient information to determine the molecular formula. For that, we must also know the molar mass of the compound. Zinc metal reacts with hydrochloric acid to form zinc chloride and hydrogen gas. The skeleton equation for this reaction can be written as X moles of zinc metal plus Y moles of hydrochloric acid going to ZnXCl aqueous plus Y over 2 moles of H2 gas. While we don't know immediately the values of X and Y, the ultimate goal of this experiment is to calculate the ratio of Y over X. The procedure for this experiment is relatively simple. First, we weigh out approximately 0.5 grams of zinc metal in a clean, pre-weighed evaporating dish. Next, we react the zinc metal with approximately 15 milliliters of 6 molar hydrochloric acid. Please be aware that 6 molar hydrochloric acid is a very strong concentration of a strong acid. All care should be made to avoid spilling this on your skin. If you do happen to spill some on your skin, immediately wash your skin very well with soap and water and inform the instructor. Third, the zinc will dissolve and the resulting solution will be aqueous zinc chloride. Fourth, we then heat the solution to drive off the water and thus recrystallizing the solid zinc chloride. Fifth, once this is cooled, the mass of the dish plus zinc chloride will be measured. Sixth, the sample will be heated 2 additional times and reweighed. This is to ensure that all of the water has been removed. And finally, the masses can be used to calculate the mole ratio. Let's proceed. First, we weigh out approximately 0.5 grams of zinc metal in a clean, pre-weighed evaporating dish. Note that the initial mass of the empty dish is 39.587 grams. We then add the zinc metal. The resulting mass of the zinc metal plus the dish is 40.139 grams. We record this in our notebook. We can now perform our first calculation. The mass of zinc can be calculated as the difference between the dish plus metal and the mass of the empty dish. The mass of the dish plus zinc was 40.139 grams. The mass of the empty dish was 39.87 grams. And by subtraction, we find the mass of zinc to be 0.552 grams. The second step is to react the zinc with about 15 milliliters of 6 molar hydrochloric acid. We carefully pour the 6 molar hydrochloric acid on top of the zinc. Note that this is done underneath the snorkel so that the evolved hydrogen gas can be safely removed from the laboratory. As the reaction progresses, we notice that the liquid bubbles and fumes as the hydrogen gas is evolved, as seen in the next clip. At this point, we allow the zinc to completely react with the hydrochloric acid. After about 10 minutes of reaction, the zinc metal has completely dissolved. The resulting solution is now zinc chloride in aqueous solution. Next, we heat the solution to drive off the water. This process will take about 20 to 25 minutes to completely vaporize all of the water, recrystallizing the solid zinc chloride. After about 15 minutes of heating, we notice that the liquid begins to thicken as the water is driven off and the zinc chloride is left behind. After approximately 25 minutes of heating, the water has been completely vaporized and only the crystalline zinc chloride remains. We must wait for the dish to completely cool to room temperature before determining the mass of the dish plus zinc chloride. This will ensure that we do not introduce any errors into our mass measurement. As you can see, the mass of the dish and the zinc chloride is determined to be 40.806 grams once it's reached room temperature. At this point, we cannot be sure that we have driven all of the water out of the crystal. So we will heat the sample 2 additional times and reweigh after they have cooled in order to ensure that the mass is stabilizing. Here we see the final data. Notice that the mass of the zinc chloride continued to decrease in the bottom half of the table. This was due to not allowing all of the water to vaporize. We do have to be careful though, because if we heat the zinc chloride to too high of a temperature, it will begin to sublimate. Notice that our third weighing, 40.752 grams, will be the mass that we use in the calculation. At this point, we're now ready to perform our calculations. In order to calculate the mole ratio, we must know the number of moles of zinc and number of moles of chlorine present in our compound. In order to determine this, we need to know the mass of both zinc and chlorine that is in our compound. In our previous calculation, we determined the mass of the zinc in the compound. We found this to be 0.552 grams. We now need to know how much zinc chloride we created. This is found by subtracting the empty dish mass from the final mass of the dish and zinc chloride. Our final mass from the third weighing was 40.752 grams, and our empty dish had a mass of 39.587 grams. Taking the difference, we find the mass of zinc chloride that we created to be 1.165 grams. The next step is to calculate the mass of chlorine in the zinc chloride. However, because there should only be zinc and chlorine in the product, we can use simple subtraction. The mass of chlorine is going to be equal to the mass of zinc chloride minus the mass of zinc in the zinc chloride. Our mass of zinc chloride was found to be 1.165 grams, and we subtract off the 0.552 grams of zinc that we began with. This means that we have a mass of 0.613 grams of chlorine in our sample. Having determined the mass of both zinc and chlorine in our zinc chloride, we're now set to determine the moles of each compound. We need the molar masses of both zinc and chlorine. The molar mass of zinc is 65.39 grams per mole, and the molar mass of chlorine is 35.45 grams per mole. These can be found on your periodic table. To calculate the moles of zinc, we begin with our mass of zinc, 0.552 grams, and divide it by our molar mass, 65.39 grams. The resulting value is 8.44 times 10 to the minus 3 moles of zinc. Likewise, to calculate the moles of chlorine, we start with our mass of chlorine, 0.613 grams, and divide by the molar mass of chlorine, 35.45 grams per mole. This results in a value of 1.73 times 10 to the negative 2 moles of chlorine. At this point, we're able to calculate the mole ratio. We will calculate the mole ratio as the moles of chlorine relative to the moles of zinc, or in this case, 1.73 times 10 to the negative 2 moles of chlorine, divided by 8.44 times 10 to the negative 3 moles of zinc. When we do this, we get a value of 2.05. This is approximately equal to a 2-to-1 ratio of chlorine to zinc. We can now return to our original skeleton equation. X moles of zinc metal plus Y moles of hydrochloric acid, forming ZnXClY aqueous plus Y over 2 moles of H2 gas. We have found the ratio of Y to X to be 2-to-1. Therefore, our chemical equation now takes the form 1 mole of zinc metal plus 2 moles of hydrochloric acid, forming zinc chloride, ZnCl2, aqueous, plus 1 mole of H2 gas. And the empirical formula of zinc chloride is found to be ZnCl2. This concludes the experiment chemical formulas. In this experiment, we have determined the empirical formula of zinc chloride to be ZnCl2. The report guidelines and data sheet will be posted on Canvas as soon as possible.